6th grade, Module 5, Lesson 18, Classwork. Opening exercise. So all of these questions are referring to this rectangular prism right here. So I don't think you have that in your book, but I pasted it right there so you can see it. So it says, what three-dimensional figure does the net create? So we're looking at this net. What three-dimensional figure does this net create? Well, it has 6 faces, and they're all rectangles. So this is going to be a rectangular prism. That is a rectangular prism. Measure in inches and label each side of the figure. Okay, so I already measured, and this is 4 inches, 1 inch, 2 inches, this is also 4 inches all the way down. Okay, so we have all of those labeled. Calculate the area of each face and record this value inside the corresponding rectangle. So it wants us to find the area of each rectangle, or each face. So this top one is 4 inches by 1 inch, which will be equal to 4 inches squared. I'll just go down. This one, next one is 4 inches by 2 inches. So 4 by 2, that would be 8 inches squared. Here we have 4 by 1, which would be 4 inches squared. This bottom one is 4 by 2, which is 8 inches squared. And then these two sides are 2 by 1, or 2 inches squared, and another 2 by 1, which is 2 inches squared. Okay, so we calculated the area and recorded the value inside the corresponding rectangle. How did we compute the surface area of solid figures in previous lessons? So how do we find the surface area in previous lessons? Well, what we did to find the surface area is we found the area of every single face, like we just did, and then we added them together. So let's say we found the area of each face and then added them together. Oh, I wrote that in the wrong one. Should have written that in D. Okay. So E, write an expression to show how we can calculate the surface area of the figure below. So how could we figure out the surface area of the figure below? I'm going to combine any like areas. So those are both 4 by 2. So instead of writing 4 inches times 2 inches plus 4 inches times 2 inches, I'm going to combine them and say we have 2 groups of 4 inches by 2 inches. Plus, so we've got those 2 crossed off. Let's see, let's highlight these. We have 2 groups of 2 inches by 1 inch. 2 groups of 2 inches by 1 inch. Plus, we have, pick a different highlighter color. We have 2 groups of 4 inches by 1 inch. So if we multiply that out and add it all together, we would get the surface area. If you wanted, you could also just write 4 inches times 2 inches plus 4 inches times 2 inches, and then 2 groups of the 2 inches by 1 inch, and write it all out and you would have 6 different things that you're adding together. I just condensed it, but either one would work. And again, I wrote it in the wrong spot, so that should be under E. F, what does each part of the expression represent? So each part of the expression represents the area of a face. So we're able to write them more compact because there are 2 identical faces of each type. So I'll say each part represents an area of one face. I wrote a more compact form because there are 3 pairs of 2 faces that are identical. Again, that was F. Okay, what is the surface area of the figure? I'll actually write it in the correct one this time. So let's take this and we're going to solve it on E. All right. So we have 2 plus 4 inches by 2 inches would be times 8 inches squared, plus 2 times 2 inches by 1 inch would be 2 inches squared, plus 2 groups of 4 inch by 1 inch would be 4 inches squared. So we would have 16 inches squared plus 4 inches squared plus 8 inches squared, which would give us 28 inches squared as the surface area. And again, sorry I wrote them all in pretty much the wrong spots. Okay, example 1. Fold the net used in the opening exercise to make a rectangular prism. So again, going with this net here. So they want you to cut it out and fold it up so that it actually makes that rectangular prism. And then have the 2 faces with the largest area be the bases of the prism. Fill in the first row of the table. So it wants the 2 largest ones to be the bases. So the ones in yellow, the ones I highlighted in yellow that are 8 inches squared, they're the largest. So those are going to be our bases. So the area of the top was 8 inches squared. So then the area of the bottom, there's 2 bases, is also 8 inches squared. So if we had it folded like that, then the area of the front would be the green ones. So if we folded it, these are the base, the yellow is the base, and then these would be what we would see on the front, and then what we would see on the back. And then these would be the sides. So back to just area of the front was 4 inches by 1 inch, so 4 inches squared. And area of the back is the same. And then area of the left side was 2 inches squared, so right here, 2 inches squared, and area of the right side is also 2 inches squared. Okay, so now what I'm going to do is fill in the equations we use to get to that part. So what we did to get 8 inches squared, that was 4 inches by 2 inches. As was the area of the base. The area of the front was 4 by 1 inch, 4 inches by 1 inch. And then the area of the left side was 2 inches by 1 inch, and same with the right side. So let's kind of take that and make it into generic equations. So to find the area of the top, I'm going to use this rectangular prism because it's formed for us. So if we were to find the area of the top, the base, here, what we're doing is we're finding the length times the width. So this is length times width, and then same with the base down below. We would do the length times the width. If we were going to find the area of the front, let me get rid of this. So this front piece right here, we're doing the length, so we'd find the length, but this time it's times the height. So length times height, and then to find the one back here in the back, it would also be the length times the height. And then to find the area of the left side, let's do right side because it's the one that's visible on this prism. So to find the area of this, we would do the width times the height. So that's the width times the height. And then the same with the right side over here, we would do the width times the height to find the area of that side. Okay, so again, let's examine this one. Let me get rid of this stuff. So let's find the area of the top. This time I'm going to do the formula first. So if I were to find the area of the top base here, this part up top, so that's like finding the length times the width. So length times width, and then area of the base would be the same, length times width. And the length is 15 and the width is 6. So 15 centimeters, I have to write smaller, 15 centimeters by 6 centimeters. And then it would be the same for the bottom. And then what is 15 centimeters times 6 centimeters? It's 90. So we would have 90 centimeters squared for both the top and the bottom bases. Area of the front, so here's the front here. So the front is the length times the height. And then that would be the same as the back because the back is identical. So that's also length times height. So the length was 15 centimeters and the height is 8 centimeters. So what is 15 times 8? Eight times 1 is 8. Oh, I shouldn't have carried a 2. It should be 120 centimeters squared. And then the area of the left side, I'll do the right side because it's visible, where you're doing the width times the height. But then we know that the left side is the same. So the width times the height was 6 centimeters by 8 centimeters. Which is 48 centimeters squared. So it doesn't ask us to find the whole surface area, but let's do it anyway because we found all of these. So to find the surface area, all we're going to do is add all of those together. So we have two groups of 90 centimeters squared plus two groups of 120 centimeters squared plus two groups of 48 centimeters squared. So we have 180 centimeters squared plus 240 centimeters squared plus 96 centimeters squared. We add 180 plus 240 first. That's 420 plus 96. So this would be equal to 516 centimeters squared would be the surface area of that rectangular prism. Example 2. I think it just wants us to find the surface area. So we know we're going to have two groups of length times width. So the point of that was to discover the formula of a rectangular prism. So we have two groups of length times width plus two groups of length times height plus two groups of width times height. That's what we came up with here. So two groups of length times width, two groups of length times height, plus two groups of width times height. And that will give us the surface area of this rectangular prism. So two groups of length times width. So we have length is 20 centimeters times width is 5 centimeters plus two groups of length times height. So 20 centimeters by 9 centimeters plus now the sides, two groups of width times height is 5 centimeters by 9 centimeters. So we have 2 times 20 times 5 is 100 centimeters squared, plus two groups of 20 times 9, 2 times 9 is 18, so that'd be 180 centimeters squared, plus two groups of 5 times 9 is 45 centimeters squared. So now let's double everything, because we have two of those, so 200 centimeters squared, plus 2 times 180, I believe is 360 centimeters squared, plus 2 times 45 is 90 centimeters squared. So 200 plus 360 would be 560, plus 90 gives us 650 centimeters squared as the surface area. All right, number 1, calculate the surface area of each of the rectangular prisms below. All right, so two groups of, we can follow this formula up here. So we're going to do two groups of length times width, so 12 by 2, plus two groups of length times height, or 12 times 3, plus two groups of width times height, or 2 times 3. So 2 times 24, plus 2 times 12 times 3 is 36, plus 2 times 3 is 6. So we have 48, and I'll put the 48 inches squared, plus 2 times 36, I think that's 72. But let's check. Yep, 72 inches squared, plus 12 inches squared. Let's add all those together. Add 48 to that. So 120 plus 12 would be 132. So this is equal to 132 inches squared. Okay, B. So let's do the front faces first, front and back. So two groups of length times width, or do the top and bottom bases. Length times width is 8 by 6, plus two groups, let's do the front. Length times height is 8 times 22, plus two groups of width times height, 6 by 22. So two groups of 48 plus 8 times 22, let's see, it's 176. And then 6 times 22 is 132. So 2 times 48 is 96, and I'll put the labels back on. Meters squared plus 176 times 2 would be 352 meters squared, plus 132 times 2 is 264 meters squared. So now we just need to add all of those together. Let's do 264 plus 352 plus 96 will be 712 meters squared. Okay, C. Okay, so let's do the bases first, top and bottom bases. Two groups of 29 by 16 plus two groups of, now let's do the front and back faces, 29 by 23 plus two groups of the sides, 16 by 23. Okay, 29 times 16 . 6 times 2 is 12, plus 5 is 17. 1 times 9 is 9, 1 times 2 is 2. 7 plus 9 is 16. So that's 402 groups times 464 plus 2 times 29 times 23. 3 times 9 is 27. 3 times 2 is 6, plus 2 is 8. Put our 0 down. 2 times 9 is 18. 2 times 2 is 4, plus 1 is 5. So 667 plus 16 times 23. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. 2 times 6 is 12. 2 times 1 plus 1 is 3. So we get 368. Okay, so we need to multiply all those times 2 because we have two groups of them. So that's 528. That doesn't make sense. So even I make mistakes, but you can look at it and be like, wait a minute, 464 times 2 wouldn't be just be 528. It should be like 8 or 900 something. So let's try that again. 2 times 4 is 8. 2 times 6 is 12. Carry the 1. 2 times 4 is 8 plus 1 is 9. Yeah, that seems more accurate. 928 feet squared plus two groups of this. 2 times 6 is 12 plus 1 is 13. 2 times 6 is 12 plus 1 is 13. So 1,334 feet squared plus 368 times 2 would be 736 feet squared. All right, so we need to add these together. I'll add 928 to that. And then I just need to add plus 100,334. And we will have added everything together. 2,998 feet squared is the surface area. All right, and D. Oh, good. This one has decimals. Okay, so let's do the bases first. It doesn't matter what order you do them in. I just like to keep it consistent. So the base would be 4 centimeters by 1 2/10 centimeters. Plus, now let's do the front and back faces. So that'd be 4 centimeters by 2 8/10 centimeters. 2 groups of them. 2 groups of the sides. So 1 2/10 by 2 8/10. All right, 4 times 1 2/10. So all I have to do, there's 1 digit behind the decimal point, so I move it over 1 spot. So that's 2 groups of 4 8/10 plus 4 times 2 8/10. 1 digit behind the decimal point, so I'll move it over 1 spot. So that's 2 groups of 11 2/10 plus 1 2/10 times 2 8/10. Now we have 2 digits behind a decimal point, so I'll move it over 2 spots, 3 36 hundredths. So now we just need to double all of those. So that's 9 6/10 centimeters squared plus 1 digit behind the decimal point, 22 4/10 centimeters squared plus 2 digits behind the decimal point, 6 72 hundredths centimeters squared. So let's just add all of those together. So let's add 22 4/10 to that. So this is really important that you keep everything lined up since we have decimal points. Keep everything with their same place values. 6 plus 2 plus 1 is 9. And then the decimal point comes straight down. So that's 29 12 hundredths. And the only thing we haven't added is the 9 6/10. Again, make sure everything stays lined up. You can add zeros in the as placeholders if you want to keep everything straight. I'll bring my decimal point down. So we get 38 72 hundredths centimeters squared. As the surface area. Number 2, calculate the surface area of a cube. All right, so we'll do it the same that we've been doing. So let's find the area of the front face. So 2 groups of 5 by 5 plus the area of the top, another 2 groups of 5 by 5 plus the sides will be 2 groups of 5 times 5. So we have 2 groups of 25 plus 2 groups of 25 plus 2 groups of 25, or 50 inches squared plus 50 inches squared plus 50 inches squared would equal 150 inches squared. So the point of that was to get us to notice that some things that we're going to answer in part 3. So let's start by noticing that we did 2 groups of 5 by 5 plus 2 groups of 5 by 5 plus 2 groups of 5 by 5. So those are all the same, which makes sense because it's a cube and all side lengths are the same. So number 3 says all the edges of a cube have the same length. Tony claims that the formula surface area is equal to 6s squared, where s is the length of each side of the cube, can be used to calculate the surface area of the cube. Use the dimensions from the cube in problem 2 to determine if Tony's formula is correct. Okay, so let's break this down a little bit. So 6, let's start with the sides squared. So if we have a side, so one of the sides is equal to 5 times 5. Well, 5 times 5 is equal to 5 squared, right? So that does work. And then do we have 6 of them? Are there 6 sides? Well, we have 2 and 2 and 2. And yes, there are 6 sides of a square. So we would do 6 times 5 squared, which would be equal to 6 times 5 squared is 25, which is equal to 150. So yes, this formula is correct. So we can say, yes, it is correct. Why does this formula work for cubes? So if each face is a square, we've kind of talked about this, each face is a square, so it's the same size. So all the sides are going to be the same, which means that we can just square the side to find the area, and then there are 6 of them. They're all the same. So let's say each face is a square, and to find the area of a square, you multiply the side lengths together. Since squares' sides are the same length, you can square them. You can just square them. Also, a cube has 6 identical sides. So you can multiply the area of one face by 6. C. Becca does not want to try to remember 2 formulas for surface area, so she's only going to remember the formula for a cube. Is this a good idea? Why or why not? So I'm going to say this is not a good idea. Even though it's a simpler formula, but it's not a good idea, because if we just found the area of one face here in this rectangle and multiplied it by 6, that wouldn't be true, because the area of this top rectangle is different and the area of the side rectangles are different. So you can't do that for anything except for a cube. It only works for a cube because all of the faces are the exact same size. So let's say not a good idea. Not a good idea. It only works for cubes because all of the faces are identical. This is not true for most, I'll say most, rectangular prisms. Because technically a cube is a rectangular prism.